Good morning, good afternoon, and good evening to everyone joining us from different parts of the world. A very warm welcome to day one of the fifth International Conference on Universal Threats in Expert Applications and Solutions, or as we fondly call it, UNI-TEAS 2026. I am Shambhavi Tomar, and it's an absolute pleasure to moderate today's online session. This prestigious conference is being organized by Shree KKarni Universe College, APEC University, and Panipat Institute of Engineering and Technology, managed by KK Consultancy Services India, and supported by the University of Rajasthan, ACM Jaipur chapter, and All India Council for Technical Education, as well as the Computer Society of India Jaipur chapter. This year, we received an overwhelming response with over 300 paper submissions from across the globe. After filtering out AI generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by Springer Nature. The first half of the day one, that is today, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity offline in Jaipur. As we step into the latter half of the day, we carry forward that same enthusiasm, ready to dive deeper into thought provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I am pleased to introduce our session chairs for this segment. We have Miss uh, Mrs. Chhabra Gandhi, ma'am, who is an associate professor at Manipal University, Jaipur. And we also have Geerija Lavania, ma'am, who is an assistant professor at JECRC Foundation, Jaipur. Okay, so before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has 10 minutes to present, and please stay within the time limit. Briefly cover your research context, objectives, methodology, key findings, and conclusion. A short Q&A may follow your talk of 1 to 2 minutes and keep responses brief and focused. Keep your mic muted when not speaking and stay for the full session to support the fellow presenters. With the kind permission of our session chairs, we shall now proceed with the paper presentations. I would like to invite our first presenter for the day, presenting the paper titled Unified Food Delivery Ecosystem Using Machine Learning under the code 327, whose presenter is Mittapalli Asritha. I would request her to kindly take the virtual stage and begin their presentation. Over to you.
Good evening, everyone. I am Mittapalli Ashrita. I'm sharing my screen. Today, I am presenting our research work titled Unified Food Delivery Ecosystem Using Machine Learning. Online food delivery platforms such as Zomato, Swiggy, and Uber Eats have each an essential part of modern urban life. These platforms provides convenience, multiple restaurant options, and quick doorstep delivery. However, hello, excuse me, Mithali. Can you please open your camera? Switch on the camera. Yeah. Then continue. Okay. These services have individually efficient and they operate independently. Yes. If user wants to compare the same dish across the multiple platforms, they must mutually or manually open their applications and search separately. This process is time consuming and inefficient. These problems motivated us to design the unified intelligent system. Problem statement. The major problem statement in the current food delivery ecosystem is absence of centralized real-time comparison system. The several challenges. First, there is no unified platform to compare price and the delivery times. Second, the same dish may appear under the different names across the platforms. Third, the price and delivery charges changes dynamically due to the offers and demands. The fourth, user do not receive intelligent profilized recommendations. Because of these issues, users may spend more money or chooses the sub-optionals. To resolve this, our objective was to develop the unified food delivery ecosystems that collects the real-time data, that normalize the dish names, compares the price and delivery time, and provides the machine learning based recommendations. Proposed systems and architecture. Our proposed system is integrate data collection, normalization, and comparison the recommendations into one intelligent framework. The system architecture consisting of the main three layers. The front end is to develop using the HTML and CSS and JavaScript. It provides a responsive and user-friendly interface where user can enter the dish name and instantly view the comparison results. The backend is to build the using fast APIs. It handles and web scraps and the data processing, normalizing algorithms, and the REST API communication. Fast API allows to asynchronous processing, which improves the system performance. For the storage database, we use the MongoDB and the Firebase. These database stores clean data and user preferences. Cache significance reduces the repeated scrapping and involves the responsive time. This modular architecture ensures the scalability, speed, and reliability. Next, methodology. Our methodology consisting of the three main stages. The first is data collection. We uses the automated web scraping tools such as Playwright and extract the real-time information including the dish names, price, estimated time, and the available for the multiple platforms. Second is dish name normalization. One of the biggest challenge in our the same dish has is having the different names across the platform. For example, chicken dum biryani and Hyderabad special biryani may refers to the same item. To address these, we apply the processing techniques such as lowercase convergence, that is dish name normalization. To address this, we apply the processing techniques such as lowercase convention, removing the special characters, and stop word eliminations. When these use normalizing techniques like fuzzy string matching, and that's it, according to the matching similarity dishes. And data aggregations and comparison. After normalization, we standard the collection data and compare the final price, include the delivery fees, estimation delivery time, and the availability. Users can prioritize either lower cost or the fastest delivery according to their preference. These structured methodology ensure the accurate and reliable comparisons. Recommendation systems and performance optimization. To ensure user experience, we implemented a machine learning based communication recommendation system. This system analyzes the user search history and the past selections over a time. It learns user preference and the suggestion optimal options, such as most cost effective or the fast delivery choice. To improve performance, we implement the caching for relevant recently searched dishes and asynchronous API calls, retry machine mechanisms for the escaping failures, and the structured error handling for the dynamic web, website changes. To improve performance, we implement these optimization reduces the response time and ensure the scalability even handling multiple requests.
Ma'am, can you explain how?
Can I show my implementation?
Can you show the results? How it is optimum?
This is
Hello,
our
can you show the results? How it is optimum as per your statement?
this is our website. As we enter the pin code or any item, it shows quickly. And we compare the different platforms. Here we show with the Burger King in Swiggy, it's 139. Whereas in Zomato, it's 200. It shows the price comparisons and the delivery time too. Through its
Okay,
way,
ma'am, go on.
sorry.
Continue, continue.
Yeah. So it makes easier to order or any delivery. The result, the system demonstrates stronger performance.
Hello. Can you please come on the conclusion side?
Yeah. The conclusion is unified food delivery ecosystem provides a scalable and intelligent solution for the real-time food comparison by integrating web scraping, fuzzy matching, and machine learning. This system simplifies the decision making and enhances the transparency. That's it. Thank you.
Thank you so much, Mittapalli, for your insightful presentation. Now we are open to questions, if any. And if there are no further questions from the audience or the session chair, we shall proceed with our next presenter. So do we have any questions?
Okay, next presenter, please.
Okay. Okay, so you can stop presenting, Mittapalli. Now we'll have the next presenter, Mihir Bordia, who is going to talk about real-time sign language recognition using hand landmark based feature extraction and classical machine learning under the paper ID 366. Over to you.
Hello everyone. Good morning. Just wait a minute. I'm sharing my screen.
Sorry to interrupt, but I would also like to recognize our session chair, Mr. Vivek Tiwari, sir, who is also with us. He is a professor at ABV Indian Institute of Information Technology and Management, Gwalior. Thank you. Now you can proceed.
Should I move for? Go ahead.
Yes.
Okay. Hello everyone. My name is Mihir Bodia, and today I'm presenting my paper on real-time sign language detection using handmark-based extraction and classical machine learning approaches. First of all,
Can you switch on your camera?
yes, ma'am. Wait a minute. Mm, Is it visible or not?
Yes, it's visible.
Oh, okay. Okay, then. Uh, my problem statement is sign language detection, and I'm using the random forest algorithm in this. First of all, we first of all, my first step in ML, you have to approach your ML life cycle. You have to approach your problem into 7 stages. The first stage is my problem definition. So my problem definition is to sign language recognition, and for this, you deaf people and the for deaf people or those people who can't speak, they have to talk to each other using the some kind of languages or some kind of some kind of communications that using the signs. So first of all, we making the machine learning algorithms, they can recognize the sign and they can talk to each other with it. So first of all, we are using media pipe in this. So my problem definition is to sign language recognition. After that, the next step is that data collection. So for data collection, I am using the media pipe hand recognition. I am dealing with the 11 signs that beautiful or beautiful and hi, hello, yes, how are you, and a no, and some kind of sign. So first of all, I collected 300 images for the all the gestures using the media pipe. In media pipe, I getting a three vectors, that x coordinate, y coordinate, and z coordinate. For x coordinate, I am getting 21 vectors. For y coordinate, I am getting 21 vectors, and for z coordinate, I am getting 21 vectors. So it become a 63 vectors Excel file. After I'm getting Excel file, though my data collection part would be done. After this, after the next part would be my model building. So for this, I'm using the machine learning algorithm called random forest. Random forest is the first of all ensemble learning model. In ensemble learning, the in random forest there are too much kind of decision trees are working with each other, so my accuracy would be high. In past, there are some kind of research are doing a very heavy models like deep learning or others, but in our model is a random forest. It will train in a just 10 to 12 seconds, so it would be very fast and a lightweight models. So first of all, this is the main thing, and after making the random forest algorithm, the next thing would be deployment. So for the deployment, I'm using the HTML, CSS, JavaScript for the front end, and using the fast API for the back end. So first of all, 21 hand landmarks and the 63 features vector would be created. So I just tell that deep learning methods like CNN, LSTM, and transformers are already there, but they are getting high accuracy, but you need a very high computational power for it. For my model is a landmark based and a classical machine learning approach. It is a very good, high on accuracy and high on a very lightweight based. So my 12 gestures are hello, yes, no, thank you, beautiful, careful, right, great, now, see, talk, us. And so after this, I have show you the my result. So I'm getting this kind of result. And this is the my train and test accuracy. In train, we are getting the 100% accuracy because we are running on the 2700 Excel file. I think 3600 Excel files. So for our next move is to this make this system to the dynamic gesture wise. So we can the two deaf people can talk with each other without talking any words. So we split the data set into 80 and 20 parts, and the after this, I create a backend for fast API and a browser-based interface for this. If your user say gesture of hello, the just I show you in this picture. If the user said of yes, the sign will recognize as yes.
So how you have collected the data for this?
Ma'am, I'm collecting data using the media pipe, using my so first of all, I go on the Google and check that the which kind of sign is using for the which kind of words. That for hello, in sign language, American sign language for hello, this is the sign. I think this sign is for the hello, and this sign is for the beautiful, and this sign is for the now. So I collected those data by my side, and I also collected data from different peoples also, that from me, my colleagues, and whatever my fellow researchers data. So I collect those data using my webcam and converted it into the Excel file. If you I also show you the Excel file for this. So just in start, I tell you that in X, Y, and Z, and we are using the supervised machine learning approach. Just X features, X0 is equal to Y0 and Z0. So we are getting 63 features. X for 21, Y
So
for
what is the parameter of selecting your features?
ma'am. It is the based on the media pipe. Media pipe is the gesture-based Google recognition system that will give you the hand gestures point by point site. So parameters would be connected by media pipe, but our the main. Mm, Sorry.
Hello, Mihir. I'm audible.
Yes, you're audible, sir.
Yeah, Mihir, she is asking, suppose you are showing the data set on the Excel file. So
Yes.
what each column talk about, like X1, X2, X3. So there
Okay.
are 63 columns. So what
Yes,
are the
yes.
meaning of each column?
So each columns are my hands movement. So if you see, just wait a minute. If you see, there is a 21 round marks. One, two, three. If you count it, there is a 21 round mark. So in X, Y, and Z coordinator. If you see, we have three directional graphs: X, Y, and Z columns. So this is the data point of the value.
Okay.
Means
So next question is that the Excel file already given to you, or
no,
some
no,
video
no.
you have taken and you have converted those
I will
video
convert it
into.
at the Excel file. The Excel file made
Okay,
by
so
me.
which algorithm you have used to convert?
So that's why the media pipe, sub the media pipe, Google media pipe algorithm using the we will
Google Media
use.
Pipe is not an algorithm.
Okay, I know, sir, but OpenCV we use the OpenCV, and from this
OpenCV is not an algorithm.
OpenCV is the library, sir. But I we use the media pipe method, sir, for this converting
Okay,
it.
so you understand the question first. What I want to ask: suppose somebody have says you like how you have implemented, who is going to do all the tasks. You can answer that is a Python. I am not doing anything. Python is doing the way
Ah,
you are
yes,
answering.
sir. Okay, so
So what is
Python.
your role? If everything is a Python is doing, so what is your role?
Sir, we are converting. We are converting. Also, we are using the LLM models. So the predicted words, the LLM models are doing the from predicted words. LLM words are making the sentence for the deaf people, so they can see it and they can talk with each other.
So means you have not developed the LLM model.
For this LLM model is using the BILSTM model, sir.
LLM model never used by LSTM. Bial STM is outdated technology. Do you know?
Yes, I know it, but
So understand the question. Don't be hurry in the answer, because
okay.
like this is my also research field. So you go and research, and you will find out there is a open pose. Open pose is the one of the method that convert your video into the skeleton. Ultimate what you are
But
presenting
sir,
on the CSV file, it is a skeleton. A skeleton word is very very famous in
yes,
that
sir,
way.
but we are not from the video. We are capturing the image, sir, and from the capturing image, the we I am using the media pipe to capture side by
How
side.
we media under the media pipe, which library you have used it now?
Sorry, sir.
And under the media pipe, which function you have called to convert your image to the skeleton?
Which function? Sorry, sir.
Which function? Media pipe is a magic something.
no. It's a
So how
library.
it works? How it convert your given image to the skeleton?
So, sir, there is a work by my fellow researcher.
Okay, leave it. What is the novelty of that work? There is a thousand of research papers are on the same topic, same data set.
Sir, we are connecting the 98.2% accuracy on it.
This is
98.8%
not
accuracy.
novelty. What is novelty? Okay, so keep on working. The research is a different dimension. Implementation is not a research only. We may be a
Okay.
UG students as you have given a lot of focus on only to on the implementation only point of view. So
Okay.
implementation is not a research at all. What idea, new idea you have taken, that idea you need to implement. So implementation is the last phase of the research. So that's why people ask what is the novelty. So
Okay.
okay, that's good work for maybe starting point of view. That's maybe good. So please keep on find out the most related paper on that area. Then you will find what am I
Okay.
what I'm trying to ask.
Okay, sir. Okay,
Okay,
sir.
thank you. We can take a next one, please.
Are you done with your presentation?
Yes, ma'am.
Okay. So now I would like to invite our next presenter for the day, uh, Geeta Chhabra ma'am and Kavita Lal ma'am, who are going to present their paper titled Unmasking the Synthetic Veil, a Comparative Insight into Deepfake Detection under the code 370. I would request them to take the virtual stage and begin their presentation.
Thank you. Yes, good evening, everyone. Today, good evening, all the session chairs, distinguished researchers, and participants. I'm Kavita Lal, Assistant Professor, Purnima University, and today I'm presenting our work titled Unmasking the Synthetic Veil, a comparative insight into the deepfake detection strategies. This work explores the evolution of deepfake generation and critically analyzed modern detection strategies. So introduction first. So deepfakes are what? Deepfakes are the AI generated manipulated images or videos that depict individuals saying or doing things that they never did. It's a combination of the word deep learning and fake. Since 2017, deepfake technology has rapidly evolved due to the GANs, that is the generative adversarial networks, which is using the discriminators and we have the generators and the discriminators. Then we have the diffusion models. Then we have the transformer architectures. So while deepfakes have creative application, their misuse also threatens the people, like the public trust, the privacy of the people, the political stability, and the financial security. These are the basic points where deepfakes are very important. Next, the motivation. The increasing realism of synthetic media has created an arms race. There are key concerns like political misinformation, non-consensual explicit content, voice spoofing fraud, and real-time manipulations. So these are the key concerns where deepfake detection should be a major point in today's world. Therefore, there's a strong need for it as for the robust detection mechanism, standard benchmarking, and ethical and regulatory frameworks. The objective of presenting this paper is particularly it's a review, a comprehensive review of deepfake detection methods have been done. the classification of different detection techniques into major categories, comparative analysis of different data sets, what data sets are being used, and the evaluation matrix, identification of technical and ethical challenges, and discussion of the future research directions. So first is deepfake generation technology. So the basic technologies are the GAN, the diffusion models. These are the technologies through which the deepfakes can be created today. We have VITs are the most probably, and then we have the variational encoders, diffusion models, and GANs. There are different multimodal deepfakes also, like visual manipulations can be done, voice synthesis can be done, lip synchronization. So these all comes in the multiple multimodality deepfakes. Now, we have classified the detection techniques into biological and physiological methods, artifact-based methods, then deep learning-based methods, and the multimodal and hybrid approaches. So first, we are going to take biological methods, like if there's a eye blinking detection or the RPP, that is the remote photo plethysmography, that is the heart rate analysis, the head pose inconsistency, as in the frames, if the head pose is inconsistent, so then what are the strengths of this particular method is that it is interpretable, but these methods are weak against advanced generators. Then the second type of methods are the artifact-based methods. This particular method include texture inconsistency, like whenever the frames are changing or the video is going on, there's an unnatural skin smoothness in the video or the irregular pose and inconsistent lighting patterns. Then we have the frequency analysis, the DCT and the wavelengths, which detect irregular patterns on the different resolutions. The strength of this method is it's lightweight, but it gives a poor generalization on the diffusion-based methods. Then comes the deep learning based methods. Probably we have the CNNs, RNNs. CNN are basically used for the spatial features, to take out the spatial features, like we want to take edges, textures, or shapes. Then we have the RNNs. RNNs basically works on the temporal mode. That is, it finds out whether there's a flickering or lip synchronization, irregular eye blinking. All this is done in the, I can name like RNN can be the LSTM and the GRU. Then comes the vision, VITs, vision transformers. These are the methods which have the global attention mechanism. So they focus on the special feature. Like if we are working on a face, so they focus on the eyes, nose, and the lips. Then we have a hybrid models like CNN transformer models. These methods have high accuracy and learns complex features. What are the disadvantages? Is there that the high computational cost is required to run them. Then we have the multimodal and hybrid approaches. These approaches combine audio-visual synchronization, lip sync detection, two-stream architecture. We are working on the voice and the audio both. What are the advantages? It provides improved robustness, cross-modality consistency checking. It means we are for the particular lip syncing, this particular audio is matching or not. So there's a cross-modality. Then disadvantages is complex implementation and scalability challenges. So this is a literature review which we have done on the different methods, like the eye blinking detection, which is based on the category of biological. Key features is analyzing blink frequency and regularity. The data set used here is face forensic. The accuracy achieved is 95.7. It fails on the high quality deepfake with realistic blinks. Then another method is a fake catcher, which is again a biological. It uses RPPG for heart rate estimation. The custom data set is used here, 91.5 AUC ROC is achieved. Then we have different, like Mesonet method is also there, which is artifact based. It's a CNN based method. So it targets meso-scale architectures artifacts. The data set used here is face forensic and the accuracy achieved is 83. It shows poor generalization on the unseen generated data. Then we have the frequency analysis. Artifact-based method, it uses DCT and wavelet transform. Then we have the exception at RNN. Then we have the vision transform, which is a method which is used more nowadays as it's the self-attention mechanism it is having. Then we have the lip syncing and the two-stream network. So these are the different methods used, data sets used, and the performance achieved, and what are the limitations of these methods. Now, the basic data sets which are used are the face forensics, CelebDF, deepfake detection challenge, ASV spoof. There are many more data sets available. Face forensic plus, it contains 1,000 real videos and 4,000 manipulated videos. So it consists of 5,000. It basically, this manipulated videos are based on the four method. Like we have the deepfake, then we have the face-to-face, face swap, and neural textures. So it's a combination of face forensic. Celeb DF, it includes 590 real videos and 5,639 deepfake videos, totaling to 6,229 videos with improved visual realism and fewer artifacts. DFDC, it contains 23,654 real videos and 104,500 fake videos, totaling approximately to 128,000 videos. Then we have this audio, which have the real audio clips and the spoofed clip, that is the fake clips. Now, what are the evaluation metrics whenever we are considering whether the particular video is deepfake or not? So these are the measures on which we need to evaluate. Is the accuracy, which measures the overall correctness of the predictions. Then we have the precision, which measure how many predicted positives are actually positive. Then the recall, that is the sensitivity, that measures how many actual positives are correctly detected. Then we have the F1 score, it gives a mean of the precision and the recall. AUC ROC curve, which gives us it's distinguish between the different classes, like we have the real and the fake class and how it distinguishes. Then last is the EER, that is the equal error rate. It is a threshold at which false acceptance and false rejection rates, providing balanced measure of system performance. Now the strategies which needs to be followed for deepfake detection, or the pipeline which needs to be followed, is first we need to input the media. It can go for the image also, it can go for the...
I request to wind up because some time is given. Within that time, everybody have to finish the presentation,
Okay,
please.
sir. Sure, sir. So this is the pipeline. Then the challenges and future directions is technical challenges is cross data set generalization, real-time detection, and computational limitation. We have the ethical challenges also, like the data set biasness is there, privacy concerns, and regulated. Now the future can be, we can use explainable eye. As explainable eye is a method which tells why this particular video is real or fake. It focuses on particular that feature. We have the cross modality learning also, and the blockchain watermarking. Through these, we can say that the video is real or fake. So final conclusion is deepfake generation is evolving rapidly due to advance in GANs, diffusion models, and transformer. Detection techniques have improved, but there's no universal solution exists. Generalization remains a challenge. Ethical and privacy concerns persist. Thank you.
Okay, in just 2 lines, you can explain the novelty of your work.
Sir, I have just, it's a review actually, it's a review paper which I have made. I have just summarized what are the different methods existing and how the different method, what are the limitations of different method. Like starting, we have the CNN, then we have the RNN. Then the people combine CNN with the LSTM model. And then now we have the vision transformers, and now the explainable AI has also come with
Okay,
like
so yeah, the question was that in the given situation, which method you will prefer the first, or maybe you change the underlying condition, and the moment you can change the condition, you have to change the underlying method also. So in that way, can you just give me like a clarity if situation is like that, yeah, data set is like that, so such kind of model may be more fruitful. In that way, do you have idea about after reading a lot of papers?
So till now, like the VITs are giving a good accuracy, but now as an explainable AI, now I'm reading about the explainable AIs also. So they are guaranteeing that the more, that because they are saying it, that whatever feature, through which feature the video is being detected as real or fake, that is more, you can say, it's sure.
Okay. So thank you. That's all from my side.
Okay, sir.
Thank you so much for your well-articulated presentation, ma'am. So if there are no questions, then I will take the attendance of all the presenters. I think we are done with the Q&A. So please answer accordingly. We have Mitapalli Ashrita with us. Do we have Arpita Agarwal? And do we have Sudhi Sharma ma'am with us? Okay, so with that, we conclude today's paper presentation session at UNI-TEAS. We sincerely
Ma'am, are
thank
they
all our.
absent? Ma'am, are they
I guess
absent
that.
in the presentation?
Yes, 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 ma'am.
Okay, so please mark absent.
Yes, I have marked them. I've noted down the names of all the presenters who were there with us in the session.
Okay, thank you, ma'am.
Yes. So we I would like to thank all our presenters and our session chairs for their valuable contributions and also for their active participation. A special thanks to our session chairs for guiding the discussions with clarity and depth. Now, I would like to request all the participants present to kindly switch on their cameras so that we can take a virtual photograph to capture this memorable session. Please switch on your cameras, everyone. Mittapalli Ashrutha. I think she's not with us. Okay, wait. Uh, yes, okay. So, thank you all. We look forward to seeing you in the next session. Have a great day ahead. You all can leave the meeting now.
Thank you, ma'am.
Welcome.